I'm going to add two new functions. One function for processing the input and another function for callback function to check if the window size is changed. And processing input important, so we start with that. Void, we just call it process input. And here we just need to pass in our window, which windows we want to do the process on. So we can just call GLFW window. We create an argument type of window and just call it window. Okay. And because we are using one CPP file and we don't have classes here yet, so I just make a function prototype on the top. Just copy the same thing, go all the way up, paste it, and make a function prototype. And let's just create another function prototype for my buffer size callback. So just call it frame buffer size callback. And in here, we need to have which window we are talking about here, GLFW window, and we're passing argument window, and we just need to check the width and height. Oh, and height as an argument. Okay, so I just copy the same thing and go all the way down and just create the function here. So for the processing the input, just to show you how it works, we just write an if condition. If GLFW get key on which window, the window that I'm passing in, and which key is being pressed. So in order to get that, we just type GLFW underscore key. Then here you can see the list of the keys we have. So let's just test one of this key. I don't know. Let's just go with A. If A pressed is equal GLFW press. GLFW underscore press. So if this key, which is A, if it's pressed, then do something, right? I can just say std. For now, we don't have any purpose for it. And A key is pressed. Std and line. Also, if you want to close the window with any specific key, we can just type if GLFW get key and pass the argument, which is window again, and which key, GLFW get. Let's just put escape key. Escape. Okay. If escape is pressed, is equal GLFW press. Then we just need to terminate the window or close the window. So then here we just say GLFW set window should close. We are passing the argument here. So which window? The window we have, and we just say true. Is an integer value, which is if you pass 1 or 0. 1 should be true, then should close the window. 3. Now all I have to do is to call this function from the loop that we have, the while loop. So I just call process input function here, and I just pass our window. And now if I run the code, And on the window, if I press A on the keyboard, you can see the message that we wrote in the cout here is printed. Yeah, the key is pressed. And if I press ESC or escape on the keyboard, the program is going to be terminated and closed. Perfect, this one is working. Now for the next part, we can start writing a piece of code here. Now to make this work, we need to go to our main and write and call that function this way. We can just write glfw set frame buffer size callback parenthesis, and we pass in the window, and here we call the function that we just created. It was, what was the function name? Frame buffer, yeah. Frame buffer size callback. And now if I run my code, and if I make changes in the window size, I can see the new values on new height and width. And this message is just to show you that it's actually working. All right, perfect. And let's move on. Now we are ready to work with OpenGL rendering pipeline and draw our objects or 3D objects. In OpenGL, everything's in a 3D space, and what OpenGL rendering pipeline does is transform all those 3D coordinates on a 2D screen. And this transformation called graphics pipeline in OpenGL. And this graphic pipeline divided to two parts. The first part is the 3D coordinates, and the second part is how to color those coordinates, which in this case we call them vertex shaders and fragment shaders. Then let's go ahead and learn more about this and code it at the same time. All right. Okay, we go ahead and create a constant character pointer, and we start writing the code for vertex shader. Constant character pointer, and we call it vertex shader source is equal, and because we are using GLSL, which is similar to C, we have to pass it to the GPU using this method. There's another method to do that as well. We're going to talk about it later, but now for the simplicity of this task, we just do it this way. All right, first thing we have to do is to specify the version of the OpenGL we are using. So we just type version 330, which is 3.3 version, and the profile is core. And we end this line and go to the next line. Here we have to assign a pose to GL position, and we do that by typing GL position equal, and we are passing a vector 3 to GL position, and we pass in a pose dot x, a pose dot y, and a pose dot z, and the last one is one is a depth and we don't use that in this course, so we just put it 1 for now. Then we go to the next line, and here we end the function, the main function here. So close the bracket, and we end the character pointer by \0. \0 indicates that this is end of this character or a string. Great, and we move on to fragment shader now, and we do the same as vertex shader. We create a constant character pointer and we call it fragment shader source is equal, and we basically do the same, and we just type version 330 core /n /n, and we go to the next line. Here we type out. We want to basically declare the outputs for the color of the pixels. So we out vector4 frag color, and we go to the next line here, and then we start the main function and just type void main /n, go to the next line, open bracket, go to the next line. Here you just say frag color is equal vector4 of the color. So as we said before, RGB and alpha. So let's just say 1 and 2 and let's just say 1. Sorry, I should put F and 1. Let's say 2. Yeah, 0.2 F, and finally is the alpha 1 F, and comma. Yeah, it should be alright. Then we close with semicolon and go to the next line, and then we just finish this by putting this brackets and /0. So we finish, we close up the function /n and /0 end of the string, and we're done. Perfect. Now we move on and continue with that in the main function and the loop.